So you've been working with systems of equations that have no solution or infinite solutions for a few weeks now. And I really just want to get at in this video how we could maybe look at a system of equations and without even solving, just kind of immediately know, oh, this has infinite solutions or this has no solution. Maybe you spotted these ways already, and that's good. That means you've been thinking about it. You've been looking for patterns and noticing things. So that's great. So you're one step ahead if you've spotted it already, but I want to maybe solidify for the people who have spotted it and kind of bring it up and show you what's going on for those who have not. So, of course, on a graph, these are already in your notes. So you know what this looks like. One solution just means they cross once. Infinite solutions means they coincide or they're the same line. They're on top of each other. And no solutions means we have two parallel lines that are separate. Of course, parallel lines do not touch. So let's look at some examples of infinite solutions. Now, of course, infinite solutions means they're the same line. And that means for a line, that means they're going to have the same slope and the same y-intercept. Those are the only two things that need to be true. Um, and here are a couple examples of maybe some ways where you would see, okay, this is actually the same line. Now, some things you would be looking for in a scenario like this is, of course, same slope, same y-intercept. But especially when you run into something like this where they're set up the same, like these are both in standard form. Here's standard and slope intercept, but these are both in standard form. You can spot that these are the same equation pretty quickly by just saying, well, the second one is just the first one multiplied by 3, right? 4 times 3 is 12, 7 times 3 is 21, and 6 times 3 is 18. So that means you could either multiply this by 3 and it would be literally the same equation, or you could divide this one by 3 and it would be literally the same equation. So they are the same equation. And we know you can multiply or divide everything in an equation to get the same thing. Um, and that's kind of an easy way to spot them. Like, okay, yeah, this is going to be infinite solutions. Somebody might have tried to trick me. Maybe one of these terms might be on the other side. But if you really notice, oh, okay, this one's just the multiple of the other, then they are the same equation, and you can just immediately say this has infinite solutions. Um, and if I had asked you, well, show your work. Um, if you say this has infinite solutions, and I know because this one's a multiple of the other, you could show this and like explain that, and that would be fine. You wouldn't have to work your whole way through it. That is showing your work. You would, as long as you're explaining what you did, say, I know this has infinite solutions because, right? So kind of an easy way to get through that if you didn't want to solve this one. You might notice as well, you might say, oh, I got -3 here. What are the steps for solving this for slope intercept form? Because of course you could grab this and put this in for y because it's it's set up for substitution. So if you wanted to go through and solve, but if you could spot it beforehand that it has infinite solutions, you wouldn't have to go through all that. So what you might notice is that, of course, our steps are to, if I want to find the slope here, I'd have to subtract over the 3x and then divide by 2. So that would result in a -3x divided by 2. So I know I have the same slope here. I know I have the same slope here. That's kind of something maybe you'd spot in your head. Subtract this -3x and then divide by 2, so -3/2 x. But I have the same slope. Do I have the same y-intercept? Well, when I divide by 2 to solve for y, that would make 10, 5. So if you can spot that in your head, then you're good. Or if you just like, well, maybe I'm not sure, you could solve. You could solve and say that's now -3x plus 10. And then when you divide by 2, -3x plus 5. That's still a little bit of work, but it's much less work than plugging this in and solving by substitution. If you were able to spot that and say, hey, you know what, let me at least check, move this one into slope intercept form and say, oh, these are the same line. And you can just say infinite solutions, and I know because blah, blah, blah. So there's a good way to spot it. What about no solution? Now, these need to have the same slope and a different y-intercept. Of course, they need to have the same slope because they need to be parallel. Otherwise, they're going to cross. Otherwise, they're going to cross. If they are not parallel, they will cross eventually. So they need to have the same slope and they need to have a different y-intercept. So examples like this. So again, it's kind of using that same idea that we just looked about a y standard form. If you think about how would I find the slope, I'd subtract over the x and then divide by the coefficient of y. So this would be -4 divided by 2. So I'd have a -2 slope here. And this would be -8 divided by 4. So that would be a -2 slope. So I do have the same slope there. And then the y-intercept, it's going to be kind of clear that these would be different here. When I get 10 and I end up dividing it by 2, that's going to be a 5. Y-intercept will be 5 there. If I get 12 divided by 4, the y-intercept will be 3 here. And so that does have a different slope. This is going to have no solution. Not different slope, has the same slope, but a different y-intercept. So if they have the same slope and same y-intercept, they'll be the same line, right? But if they have the same slope and then a different y-intercept, they'll be a separate line but parallel. That's going to result in never touching and no solution. So you just got to check slope, y-intercept, make sure you're good. This one's kind of clear. I've got a -3 slope and a 15 y-intercept. Sometimes you'll see that they have the same number here, and that might trick you and think, oh, okay, infinite solutions. Because, yeah, okay, subtract over the x, that's -9 divided by 3 is -3, same slope. And then some people might just look, okay, 15 and 15, same y-intercept, and the infinite solutions. Now, don't forget, this 15 is going to be divided by 3. If you're moving this into slope-intercept form, that 15 will be divided by 3. So this is a y-intercept of 5, actually. And this y-intercept is 15. So we do have a different y-intercept. This has no solution. And again, if you don't want to go through and solve and just say, oh, this has no solution, just explain why. Okay, yeah, I know this has no solution because this. I can tell that it has the same slope and a different y-intercept, because of whatever. You can just explain yourself. That is showing your work if you're explaining yourself. And of course, it has one solution if the two lines don't have the same slope. That's the only thing that needs to happen. If they don't have the same slope, then they will cross. Because if they're not parallel, here's parallel. If they're not parallel, they will eventually cross. Like even if it's just like barely, we could go on, and it's going to cross somewhere if they're not parallel. So it will have one solution if the slopes are not the same. So go ahead and use these strategies as a way to hopefully save you a little bit of work in working through them all. If you can spot early on that they either have infinite solutions or no solutions, hopefully that'll save you a little bit. And we're going to practice just a little bit below.